Thank you very much, everyone, for attending this webinar. Good morning, good afternoon, or good evening, wherever you may be. As we know it, oil is a very important commodity. And that's the reason why we make an expensive effort to find it, bring it up from the ground, process it, and then send it to our consumers for their needs. It is during this process that uh, accidents does happen. And during these accidents, this very important commodity that we have, once it goes out of our system, it becomes our worst enemy in the form of an oil spill. So in this webinar, what we will be talking about is the oil being our enemy in a form of an oil spill. So what could be better than knowing how the oil behaves once it goes out of your containment? Okay, to understand the characteristic, to understand more better our enemy or the oil in the form of an oil spills, what I have here in front of you is an example of the oil laboratory report, wherein it actually contains a lot of oil properties. But we don't need to understand all of these properties. We just need to understand properties which is relevant to oil spills. And one of that property is the density. Another is the viscosity. Also, 4 point is very important for us to know: the asphaltene content of the oil and the volatility. Okay, but let's not forget that sometimes oil do has an H2S, which becomes very dangerous to the responders. Okay, so the key properties that I have mentioned is the specific gravity, viscosity, 4 point, volatility, and asphaltene. So specific gravity, it tells us how heavy or what is the density of the oil. This determines if the oil will actually float or sink in the water. So as we know, if the oil floats or if it sinks, the strategies or the tactics that we will be using is different. Also, heavy oil could sink and cause sedimentation and damage our seabed. Lighter oil floats, thus it could be affected by the wind and the current. And at the same time, this wind and current could carry this oil, this floating oil, and hit our sensitive shorelines or our sensitive structures. The next property is the viscosity. Viscosity is, it tells us how thick or the resistance of the oil to flow. Less viscous oil tends to spread wide and then evaporate faster. So this covers a wider area. And low viscosity oil could easily break, thus enhances biodegradation and dissolution. Also, the high viscosity could increase the chances of sedimentations, especially if it interacts with the um, the dirt on the water, and it becomes heavy, those causing it to have a sedimentation. Just to show you the differences between viscosities, I'm going to show you a short video clip here, just to differentiate how the oil moves, if it's very viscous and if it's very light oil. So on your left, the viscosity here is 1 centistoke, but as you go to the right, it becomes thicker and thicker. And have a look how it moves. On your left side, it immediately goes up, but here on the right side, it doesn't move at all. It moves very slow. So that's the difference between the low viscosity and the high viscosity oil. In fact, in one of the last incident that I have attended, we have the oil which is very viscous, and we cannot we cannot recover it using machinery. So what we have done is recover it using a fish net. So we scoop the oil and then transfer it into our temporary storage, which is a drum. But if you just simply pour it into the drum, it will not move. So if you see the photo here, what we are actually doing is we are squeezing the oil out from the fish net because it's very sticky. So the next property I will be talking about is the pour point. Here, the pour point is the temperature below which it does not flow. Meaning this one, it represents the lowest temperature at which the oil is capable of flowing under gravity. Oil with high pour point spreads less on colder water, since when it hits the colder water, it solidifies, thus it will not spread. I'll show you two short video clips to compare the same oil poured into the warm and to the cold water. So here, this is the oil that we pour into a warm water, and have a look at the result. It slowly spreads. So can you imagine if this happened in an open water? It could spread faster. Could spread faster, and it covers a wide area. And the next one is that same oil, we pour it into a cold water. Here, the oil pour point is actually higher already than the water. So if you look at it, it actually solidifies. So, and at the same time, it prevents it from spreading. One issue with this is it's not easy to recover once the oil had already solidified. The next property we will be talking about is the volatility. Volatility is the propensity to evaporate. Okay, so light oil tends to evaporate faster and cover a large area. But when the oil is evaporating, the advantage of it is it reduces the volume, and it also reduces the waste to be recovered, to be contained, I mean. And very light oil doesn't need a physical response as it evaporates fast. I mean, not all very light can just easily evaporate, but normally most oil will just evaporate very fast. Okay, for example, like petrol, condensate, they evaporate very fast, and we don't really need to have a physical response to this type of oil. But the downside is the observer or the public actually think we are not doing anything. That is the downside of this, if we are not showing the public that we are actually monitoring the situation, and then being ready to deal with it once the situation changes. And lastly, we are talking about the asphaltene content of the oil. This is the propensity to emulsify. If the oil has an asphaltene above 0.5%, oil could create a stable emulsion, meaning it's very hard for us to separate the two. But if it is below 0.5, it could still create an emulsion. However, there's still a chance that we could separate them. Okay. And once the asphaltene also changes the properties of the oil, such as the viscosity and its density. And once the oil, the asphaltene content is high and it emulsify, it increases the volume and also increase the waste storage capacity that we require. Okay, so how are these properties relevant to oil spills? So these oil properties that we have mentioned earlier are the main factors on the weathering of the spilled oil. So once the oil is spilled, depending on the quantity, there is a chance that we cannot remove it immediately. So if we cannot remove the oil immediately, it means it will get weathered, and then it changes it changes its characteristic. Also, the optimum use of response strategies depends on all these oil properties. Okay. Now we will be talking about the optimum response strategies depend on the oil properties. Okay. So how do these properties shape our response? On the left side, you see the property. On the right side, you see the possible strategies likely to use. Okay, I will highlight the word possibilities because it doesn't mean that with that specific gravity, uh, all of these possible strategies that I have mentioned is applicable. It's because there's a lot of factors that may affect your response or your operation. So it's really the proper assessment of the whole situation that you can decide an efficient way of removing the oil from the water. But knowing these properties, it gives you already an idea. So for specific gravity, heavy oil, you could actually use containment and recovery using mechanical skimmers or mechanical recovery devices. For light to medium oil, we could use a monitor and evaluate dispersant, in situ burning, and containment and recovery. Again, I will reiterate, not all of this is applicable to all types of oil, and that's the reason why assessment is very important. The next property is the viscosity. Knowing the viscosity of the oil, for high viscosity, we could use the containment and recovery, and then manual recovery. As if you still remember the previous photo that I have showed you, that we actually squeezing the oil out from that fish net. Also, low viscosity, we could use mechanical dispersion, dispersant, in situ burning, and containment and recovery. For the oil with a very low viscosity, sometimes we need just energy to deal with it. So if there is no natural energy that is created by the wind or the current, we could use a mechanical, uh, like a vessel, like a boat, to create an energy to do a mechanical dispersion. The next is the pour point. For oil with a high pour point, we could use containment and recovery using mechanical skimmers and manual recovery. Since we understand that if the oil has a high pour point, the possibility of it to solidify when it hits the color water is very high. For the low pour point, we could use dispersant, in situ burning, and containment and recovery. As for the volatility, okay, high volatility oil, we could use monitor and evaluate, for the reason that if the oil is evaporating, it is very dangerous for responders to come in. So we need to monitor and evaluate the whole situation. And then if we think that it's already safe for us to come in, that's the only time we can go and then uh, remove the oil if necessary. Okay. For the oil which has low volatility, we could use dispersant, in situ burning, and containment and recovery. Lastly, talking about the asphaltene, oil with high asphaltene, we could use containment and recovery because the chances of it for it to emulsify. And then for low asphaltene, we could use dispersant, in situ burning, and containment and recovery. So those are the properties that actually shape our response. Again, I will reiterate that we need to have a proper assessment to have an efficient response. Okay, just to check with you, if you actually remember something that I have mentioned just earlier, can you bring out your phone and then scan the code and answer? There's only two questions that you need to answer. Okay, so scan the code and then give me the answer. I'll give you around 3 minutes to do that. Okay, let's go and have a look at the result. Okay, so we have 24 people who answered the questions. And then on the first question, which property of oil has a propensity to emulsify? Now we have 26 people. Okay, 88% of the respondents, or 23 out of 26, answered. Wow, it's updating very fast. Now it's 89% of the respondents, or 24 out of 27, answered the questions correctly. Okay. And as for the second questions, by the way, the correct answer is the asphaltene. Okay, asphaltene is the property of the oil that is the propensity to emulsify. And as for the second question, the property of oil that has the propensity to evaporate, almost everyone got it correctly. 26 out of 22 got it correctly, which is volatility. Very good. So very good memory. You remember, almost everyone remembers everything. Okay, so let me just go back to my presentation. Now we will talk about what will happen to the oil once it's spilled into the marine environment. As we know it, as the oil stays longer in the environment, in the marine environment, it's got weathered, or it changes. Okay, so the fate of oil in the marine environment is, in addition to the oil properties we have already highlighted, the fate of the oil spilled into the marine environment depends on other factors, such as the prevailing environmental conditions, such as the wind, turbulence, tidal streams, and current. Also, the temperature of the water. And the release conditions also, it also depends on the release conditions, which is it's either continuous or instantaneous. And at the same time, it also depends on the volume or the quantity of oil that has spilled into the marine environment. Okay, so let's take this for example. If we have an incident, a vessel incident, what could happen to the oil if the oil spilled into the marine environment? So looking at this, once the oil goes out of its containment, it could spread, it could evaporate, photooxidize, fragmentation, get stranding, emulsify, sedimentation, dissolution, dispersion, and biodegradation. So these are the things that could possibly happen to the oil once it's spilled into the environment. But again, it depends on the oil that has spilled into the marine environment. Maybe not all of this will happen. Okay. It depends on the type of oil. Okay, so when we say spreading, or sometimes not only spreading, but also the oil gets fragmented, low viscosity oils can spread fast and wide. Okay, this is because this is affected by the wind, the turbulence, and the current. It also, once this happens, it increases the complexity of the response, such as we need more surveillance assets, and also we might need multiple response teams in different locations. Evaporation. The rate of evaporation is influenced by the volatility. The oil which has a high volatility, it means there's more evaporation. Okay. Rate increases with higher ambient temperature and or wind speed. So, for example, the oil spilled into a colder environment, such as, for example, in the North Sea, and the same oil spilled into the Middle East, for example, in the middle of summer. Both this same oil has a different evaporation rate it depends on where it is spilled. And spreading will also affect the evaporation. Residues after evaporation will have a higher density and viscosity than the original product. Since the light ends had already evaporated, the the heavy portion of the oil will be the one left, and then that will have a higher density and viscosity than the original product. The next is the natural dispersion. Oil in the sea surface broke down into small droplets by waves and turbulence. Okay. Uh, I have one classic example of this. During the uh, sometime in August 2012, there is a diesel spill in the Manila Bay in the Philippines. And actually, the people are collecting this oil and then selling it to the recyclers. However, after around a week, the typhoon comes. And for those who are not familiar with the Philippines, okay, Philippines is considered as the typhoon capital of the world, maybe because for the reason that we are running out of names sometimes, because of so many typhoons that hit us. So when the typhoon comes, um, this generated a lot of energy in the water. And then when the typhoon subsides, you look at the beaches, you look at the waters, it is very, very clear. Seems like nothing had happened. So the people are actually surprised what happened. But for us, we know that the oil had undergone a natural dispersion because of the energy that has been created by the typhoon. Okay. So this natural dispersion is it increased droplet surface area created by dispersion and promotes biodegradation. Okay. So it promotes biodegradation and dissolution, and at the same time, it's sedimentation. Okay. So as I stated in my example, think about if the spill is not diesel. Say, for example, that spill is heavy oil. What do you think will happen? I don't think it's only sedimentation, but I think what will happen is those structures close to the sea will end up with a lot of oil also. In the absence of strong wave and turbulence, this can be enhanced by mechanical agitation or commonly known as prop washing. So to have a natural dispersion, we need energy. But sometimes you see that the water is very calm, there is no energy at all. So it means natural dispersion is not that effective. So you need to create an energy by using your boats, your vessels to do a mechanical agitation. Emulsification. What is emulsification? Is the water in oil mixing each other. Okay. So when this happens, the total volume of the spill could actually increase by as much as 4 to 5 times. And the key factors driving this emulsification is, as we mentioned earlier, is the asphaltene content of the oil and also the sea state. Okay. As we mentioned in the properties, if the asphaltene content is more than 0.5%, it is likely to create a stable emulsion. However, asphaltene content only cannot create that emulsion. We need energy. We need a mixing energy. So a sea state of Beaufort level 3 or above accelerates this process. So we'll often see the color change to an orange or brown product when the oil emulsifies. The next fate that could happen to the oil is stranding or sedimentation. Okay. So as much as possible, this is the fate that actually we don't want to happen. So when the oil is spilled into the marine environment, we make so much effort to remove it before it hits the sensitive shorelines or the sensitive structures. Because stranding, it increased the impact on environment and the people. In rough seas, it may become submerged for some time, resurfacing when conditions improve. But if the oil is if the oil is uh, not so viscous, the chances are it could actually just naturally disperse. Okay, and stranding and sedimentation can promote a formation of charboils which settle in the seabed, possibly washing up on shorelines weeks to months later once there is a change in tides. And lastly, uh, biodegradation, which is the ultimate fate of oil that we want. Biodegradation is oil-eating microbes and bacteria increase in number with more oil available. So bacteria is eating the oil, and it is food for them. So when there is food, the bacteria thrive, and then they metabolize the oil, suspend into the water column. Time taken ranges from days to years depending on the oil type, temperature, nutrients, nutrient content, the area, and the oxygen level of the water. Also, spilled oil is broken back down into water-soluble compounds and eventually to water and carbon dioxide. Okay, so how do this weathering process affect the response? So we will take spreading, for example. Spreading, as we know, it covers a large area. And oil could split into patches. So what is the significance is we need more resources on this. We need more skimmers, we need more booms, we need more vessels. Okay, and also large or wide area to monitor. If the oil spreads very wide, we will be monitoring a very wide area. And offshore operations may require a greater aerial support. As for the evaporation, as we know, the volume decreases. Okay, but again, the surrounding becomes volatile. So what is the significance to response? When the volume decreases, it means we need less resources. Also, we have less ways to manage. But because of the surrounding, which is very volatile, responders are exposed to a more explosive environment. And a very significant consideration before you go in and respond to that spill. Lastly, we'll talk about the natural dispersion. Natural dispersion, as we know, the oil just naturally breaks down in water column because of the energy. And what is the significance of this is with the right amount of wave energy, we may require little or no response action at all. Again, it's depending on the oil. But the disadvantage is the public in the media seen as to be doing nothing, and it's not good for the public's eye. Okay, so that's the end of my presentation. So we have takeaways is we have identified the key properties of oil relevant to oil spills. And those are the 5 key properties, which is the specific gravity, the viscosity, the pour point, volatility, and the asphaltene content of the oil. And also, we understand how its properties shape the response decisions and how does these properties affect the weathering of the oil. Okay, so the next part is a discussion, the questions and question and answers.
Well, can I invite you to submit your questions on the chat box if you have any questions? Just out of as a layman, I was just thinking if there is a mixture of different oils, for example, in an oil spill, there can be could be a spillage of more than one type of oil. So how do we determine the properties in this case, and how will they impact the oil spill response?
Oh, that's a good question, Sharon. It's not impossible to have a mixture of different oil when an incident happen. So as I mentioned earlier, a proper assessment before you start your decision or you start your operation. So understanding what are the properties of each oil is a very big advantage. But not only that, we could actually try some of those strategies in like for example this percent. If we want to use this percent, we could use a sample of the oil and then try it on that oil, try this percent on that oil and see if it's working. Then if we see it's working, it means we could actually use that response strategy.
Thank you. And we have more questions coming in now. One from Ricardo. He mentioned inland oil spills behave the same way as marine oil spills. Do inland oil spills behave the same way as marine oil spills?
Okay, so inland oil spill, say if it happens in a lake.
Inland waters oil spill, sorry.
Yeah. So if it happens, because lake is actually considered like an inland spills on rivers, um, the behavior is a bit different from a marine environment. Okay, and also most of the inland spills is most of the inland waters are fresh water, not salty water. So at the strategies sometimes that we are using is slightly different from the marine spills.
Okay, the next question from Jeffrey. What is the most important property of oil we need to consider for oil spill response strategy? Is there like a ranking which is more important, which is less?
Okay, so when you talk about the ranking, there is no such thing. Uh, the 5 properties that we have actually identified are very important properties. Okay, so there is no ranking that we say, oh, this is the very important one. But when we say we understand that the specific gravity of oil is lower than the specific gravity of water, it means it tells us that it floats. But then another property, which is the viscosity, if it is very viscous, okay, uh, it floats and then it's kind of sticky. So it's not a ranking, but rather you try to understand everything and then incorporate all the information in your decision making.
Thank you, Edgar. And there's a question on dispersant. What type of dispersants do you recommend for oil spills?
Oh, I think as we know it, there's so many dispersant manufacturer in the world nowadays. Okay, and the oil cannot be easily dispersed. Not all the oil can be dispersed by all the types of dispersant. So the best thing to do on this is actually uh, take a sample of your oil, your specific oil that you want to use that dispersant, and then try the dispersant that you have, if it's working or not. Okay, as I mentioned, when you talk about dispersant, it's not across the board that it can disperse all the types of oil. And at the same time, um, even though the oil can be dispersed using dispersant, not what you call this, not not all the how should I say this, oil with a specific gravity which is very heavy. It's not uh, it it's not efficient. It's not efficient if you use this percent because you cannot break it into tiny droplets. And as for the oil which is very light, we actually don't want to waste our dispersant because it will just naturally disperse in itself.
Okay, thank you, Dwight, for this question on dispersant. For the different types of dispersants, do we have different type of application, the methods of application, and does a type of dispersant dependent on the type of equipment we have on hand?
Oh, okay. So what we have is we actually in oil spill response we have quite a few types of dispersants also, but this dispersant can be applied to any platform that we are using, either the use of spray arms, the use of this Afido nozzles, or other means use of the aircraft, the heli bucket, it doesn't matter what type of dispersant we're using. Okay, the platforms that we have can actually be used on all the dispersants that we are using.
Okay, thank you, Edgar. If you have further questions about today's webinar, questions about oil properties, feel free to contact Edgar. Edgar, thank you very much for your time.
Yeah, thank you very much, Sharon, and thank you very much, everyone, for attending